Hi Calcers. All right, so we're going to do a little mini lesson today on use substitution when you have bounds. So the first one we have is the integral from 0 to 1 of x times x squared plus 1 raised to the third dx. All right, so for use substitution, we have to figure out what the inside is. So u equals x squared plus 1. So then we're going to take the derivative, du dx equals 2x multiplied by dx. Du equals 2x dx. All right, I'm going to substitute in what my u is. So this is going to be u to the third. And then I have x and dx. And remember, we can't have those mismatching variables here. So I have to figure out what x dx is equal to. So I'm going to divide by 2, so we get 1/2 du is equal to x dx. So I'm going to substitute in 1/2 du for x dx. All right, so now same idea with the bounds. We can't have mismatching variables. So these bounds up here are technically saying what x is equal to. But if I put 0 and 1 here, then those would be x's and these are u's. So what we need to do is figure out what our lower bound would be in terms of u. So I'm going to take 0 and figure out what u would be when x is 0. So 0 squared plus 1. So my lower bound would be 1 and my upper bound would be 2. All right, so now I'm going to take the antideriv. So I add 1. Divide by the new exponent, so dividing by 4 is like multiplying by 1/4, so we got 1/2 times 1/4, that's 1/8. Now, with this, when we have bounds, you don't need the plus c. And when we have those bounds, since I already changed them, I don't have to do any substituting back in because what I want to do is find just what the evaluated value is. So I'm going to evaluate this from 1 to 2 because this is u, so then I can keep these as my u value. So I'm going to plug in 2, so it's 1/8 times 2 to the 4th minus my lower bound, plugging that in, 1/8 times 1 to the 4th. So I get 2 to the 4th is 16 times 1/8 is 2 minus 1 to the 4th is 1 times 1/8, that's 1/8. So 2, that's 16 over 8 minus 1 over 8. So that's 15 over 8. Final answer. Okay. So for number, let's see, I said I would do 1, 3, and 6. So for number 3, same idea. What we're going to do is the integral from 0 to 2 of x over the square root of 1 plus 2x squared dx. All right, so I'm going to rewrite this as the integral from 0 to 2 of x 1 plus 2x squared to the negative 1/2 dx. Okay, so my u is equal to 1 plus 2x squared. So that's going to be u to the negative 1/2. And then I have the x dx, so I'm going to do du dx equals, for x, I multiply by dx, du equals 4x dx. So I'm going to divide by 4. So I get 1/4 du is equal to x dx. So I plug in for x dx with 1/4 du. And I do the integral of that. And now I don't want to keep those bounds in terms of x, because remember those are x equals. I want to know what they are in terms of u, so I plug it into my u to find out what that would equal. So 1 plus 0, that's going to be a lower bound of 1. And plug into 2 squared is 4, times 2 is 8, times plus 1 is 9. All right, so now we add 1 to the exponent and divide by the new exponent. Dividing by 1/2 is like multiplying by 2. 2 times 1/4 is 1/2. And now we're going to evaluate that from 1 to 9. So I plug 9 in, so 1/2 times 9 to the 1/2. That's my upper bound, minus, plug in my lower bound, 1 to the 1/2. So I get the square root, because 1/2 is the square root. Square root of 9 is 3. 3 times 1/2 is 3/2. Minus 1 square root of 1 is 1 times 1/2 is 1/2. So 3/2 minus 1/2, that's 2 over 2, which is final answer of 1. All right, last one is a trig one. All right, maybe I'll break that into a second video.